When last we met, we were talking about significant figures and measurement, and how measuring, when you measure something, we're supposed to estimate one past the most precise measurement you can make with the instrument. And then when you use that information, you have to be able to count significant figures when you start using math with it. So now we're going to switch from why is a number significant to counting with significant figures. We'll start here. Rules for counting significant figures. Non-zeros are always significant. Zeros, leading zeros never count. Okay, and I have another way to remember this that I'll show you in a moment. But if you have zeros to the left of a whole number, they're not going to count. Sandwich zeros always count. Trailing zeros only count if there's a decimal. Okay? Why is this? Well, if you rewrite 0.0025, that's 25 10/100,000ths out of 10,000th. All right? If you were going to write that out as a fraction. Okay? Yeah, these zeros don't make any difference whether they're there or not. If I'm going to do this, though, $250 out of, somehow I changed my pen. Oops, I don't need that. Get rid of that. There we go. This zero does make a difference because 25 out of 100,000 versus 250 out of 100,000, that's a different number. So that is the reasoning behind this. Now, it's tough. People forget all the time. So here's the secret. This is actually came from my son's chemistry teacher at Olathe East, and it revolutionized the way I taught all of a sudden. All right. Here's the United States. The Atlantic Ocean is on the right-hand side. The Pacific Ocean is on the left-hand side. All right? If a decimal is present, then we start counting from the Pacific side. So the decimal is present, we count from the left. If the decimal is absent, we count from the Atlantic side. So let's look up here, and we'll count in this little section here. 200. Do you see a decimal there? No. So decimal is absent. We're going to start counting, and we start counting at the first non-zero. So nope, 1. We have one significant digit in that number, 200 grams. 180 grams. We're going to start from the right. Again, no decimal. That one doesn't count. 1, 2. We have 2. This one had 1. This one has 2. Again, no decimal, so we start from the right. 1, 2. Again, no decimal, we start from the right. And we have 1. All right? Now, the next row, we have a decimal, so we're going to start counting from the left, and we're going to count starting with the first non-zero. 1. So that guy has one significant digit. 1, 2. 1, 2. 1, 2, 3, 4. 1, 2, 3, 4. All right. The next page talks about an exact number. That's something that has been counted. It has an unlimited number of significant figures. 3 apples is a significant digit. I don't know why it says 3. 3 apples would have one significant digit. I don't know. That's a brain fart there. 1 inch equals 2.54 centimeters. These are both going to be considered this is a conversion way to change inches to centimeters. These are both going to be considered unlimited significant figures. You don't use these when you're calculating. All right? All right, here's some more practicing. We have a decimal, so we're going to start from the left. 1, 2, 3, 4. 1, 2. 1, 2. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. All right, when we add and subtract things, which isn't going to happen in College Chem very much, we use whatever the least decimal place is. For instance, this one here, adding up 12.11, 18.0, 1.013. This is the least significant of the three numbers. It's the least precise, so we ignore those guys. Okay? Subtraction. This guy is less precise, so we ignore these guys. 6.6 minus 0.1 would be 0.5. However, if you do the math and then ignore them, that would round up to 0.6. Multiplication, you just pick the smaller number of significant digits. This will be important because we get to moles. You all remember calculating moles from molar mass. Molar masses have unlimited significant digits. You have to keep track of that. My general default is 3. So if you're ever in question, use 3 significant digits. Now that doesn't mean 3 decimal places. 3 significant digits. So if you're doing a math problem and you're not sure, go to 3. Just a hint. All right. So we're going to take a look at this worksheet. Do a few of them together. Determine the number of significant figures in the following measurements. Cross out any zeros that are not significant. Explain why they are or are not significant. All right, well, if it's not, a 0 isn't significant, it's because it's a placeholder. If it is significant, it's because it's helping make the number more precise. Here we have a decimal, so we start from the left. That 0 is not significant. We have 1, 2, 3, 4, 5 significant digits. Placeholder. Again, placeholder. 1, 2, 3. Again, placeholder. We have 1. 1. 2, 3, 4. I started from the left because there's a decimal there. That 0 is a sandwich 0. They're always significant. This was an interesting one. Decimal is present, so we start from the Pacific side. 1, 2, 3. These zeros are placeholders. These zeros tell how precise the measurement was. That guy has 2, that guy has 4, no decimal, 1, 2, 3, 4, 5. Okay? I'm going to let you do the rest. There's even some down here that have, there's 2 with subtraction, 1 with addition, and then multiplication and division. I'm going to let you go ahead and do those. And then you have another one that is like a puzzle that I want you to work on. So there you go. Thank you very much.